I'm going to start recording now. Okay, so we're going to go over the comprehensive problem set for this one. So this is the traditional final, one your guys are probably not used to taking in this college. Most finals you guys take in the college don't go over all materials that was covered in class. This one will. The caveat is it's much easier than other finals you would have taken. What normally happens in pre-COVID times, that seems so long ago, was you guys took a test at the beginning of the semester, this is the test at the end of the semester, and we're just measuring how much you guys learned. What the test is, it's a standardized national test. So you guys have taken national tests at schools before. Same thing here. It's just to see how well the chem teachers are teaching what to fix and what not to fix. It's a very easy test. Usually GCU students do really well. We do about above average and at average, which is pretty good.
Wasn't that last semester, the chem one, that was like the final test?
Yeah, ACS test, yes. It's called the ACS test. That's what it was, basically. This is a different one. And so basically a lot of these problems we're gonna go through, it's gonna be through the entire, well, all of Chem 115. The way I'm going to do it is, even though some questions are very obvious what the answer is going to be, we got to talk about why the question's being asked. Because the questions are going to be asked in a weird way. Make sense? Okay. If you guys have questions, answer up, follow along.
Will this help us for the exam?
Yeah, this is the best way to study for the exam. Because it's go over everything. So, to make my point even obvious, let's actually make it a bit bigger so we can see it. Said what? Let's play this concept, yeah. Okay. Number one. What is the concentration of calcium ions in a 35 milliliters of aqueous solution containing 75 grams of calcium carbonate? This is a Chem 113 question, actually. So, what am I looking for? Which is what? Concentration always equals what? No. Moles over liters. That's molarity. If it's grams over liters, that's molality. There's molarity and there's molality. Do not confuse those two. They sound very similar, but they are very different. Okay. I'm getting a lot of questions in the final grade. I don't know. That's lame. So he takes however long to grade you guys' test. It's however long it's to take to grade my test. Okay. So we'll see we'll see if you notice any mistakes. Yeah, I know.
They fixed them for one of the other ones.
Oh yeah, Monday students got screwed over a lot.
Oh yeah, that's great.
Yeah. We get a little bit more leeway. Okay, so concentration of that, I'm given volume, but is it the correct units? So what do I do? Madison, you've always struggled with this. How do I go from liters to milliliters to liters?
I was literally thinking that right now, and I am going to go with dividing by 1,000.
Got it right.
Bam.
Yeah. So 0.35 liters. Okay. Oh no. This is something you guys have not done since Chem 113. I have grams. I want to go to moles. How do I go from grams to moles? Molar mass. Where does molar mass come from? The periodic table of elements. Yeah, I know. Things come back from 113. So calcium weighs roughly 40 grams per milliliter. Chlorine weighs about 35.5. You're going to double it. You're not going to square it. We never hit the square button in Chem 113. 111? You sure? Yes, it is. So the molar mass of calcium chloride is 111 grams. So 7.5 grams 1 mole divided by 1 grams, cancel, cancel, gives me how many moles? Yep, I'm going to change my color, go to red, 0.068 moles, divide that by my liters, 0.35 liters. What is my concentration? What is the answer to this, guys? 0.194 milliliters. Okay, we're gonna remember that number. I'm gonna clear my drawings. 0.194. Okay, that is the concentration for calcium chloride or dichloride. Do I do anything with that number? Do I? How many calcium ions do I have? In this, I have 1. So I don't do anything. If I was looking for the amount of the concentration of chlorine ions, I would multiply by 2, because there's twice as many chlorines as there is calcium. Does that make sense? It would multiply by 2, because it'd be twice as much. Because for every one of these, I should have twice as many chlorines. Does that make sense? Because this one component is 1 part calcium, 2 parts chlorine. Make sense? Okay, so you need to know what you're looking for, because this question could be asked in the same way, but just looking for the chlorine ions instead of the calcium ions. Okay, everyone got that? Okay, now we're gonna go back to everyone's favorite unit, acid and bases. So this was literally pulled from the final for lecture, or from lab. What is this? Titration curve. So titration curves. What do we usually add to it? We add an acid to a base or a base to an acid. We never add acid to acid or base to bases. They wouldn't do anything, right? So next up, you guys want to notice, how many equal equivalence points do we have? 1, 2. What does that tell you? It's diprotic. Okay, and what did that just do? It eliminated all the answers. I can't tell you because I'm recording it right now. Because my Friday students can also watch this video and find out. So the diprotic. Is it going to be a strong or weak acid?
What defines a strong acid?
It has to have a very low pH.
But what does low pH consist of? Like below 0?
No, below 0. That's a super acid. That's analytical chemistry. Usually when they're closer to 5, they are weak. When they're less than a 5, they are usually strong.
So 5 is where it
Kinda. Usually it's a good way to estimate it. The best way to estimate it, though, is what am I titrating with? Okay, where's the first equivalence point? Around 7, right? Which means I'm titrating strong and strong. Does that make sense?
Yeah.
That's the best way of telling if you actually are using a strong acid and a strong base. The equivalence point should be 7.
Okay. Because I was wondering, like, what makes it a strong acid? Like, what number differentiates strong?
It depends on the temperature you're dealing at and the concentration of it. Because I have a really weak acid, a really high concentration of weak acid, and that can be much more dangerous than a low concentration of a strong acid.
Okay.
Also, I could get a strong acid and we'll get like at almost absolute 0, it wouldn't do anything. Or I could crank it up and make the acid boil, and that's even worse. Boiling acid's pretty bad. So, okay. Number 3. So what is the pH of a solution of 0.2 solution of C6H5COONA? And the Ka is this. So there are a couple things to do. First off, let's talk, before we solve the problem, let's talk about acids real quick. I'll put green for acids. Okay. If you have a strong acid, what do you do immediately? What's a strong acid do? Dissociates 100%, right? which means, for example, hydrochloric acid, no matter whatever concentration I get here will be here, right? Which means I can just take the negative log of my H concentration and I should get the pH of the acid. However, with weak acids, they don't dissociate 100%, right? So I have to use Ka is equal to X squared over HA. Or, we don't know this, products over reactants. Because this X squared is the products of H and A over what we started off with. That makes sense. Okay. Problem here, though. I'm looking for pH. What is this? That is a salt, but is that an acid or is that a base? That is a base. We know it's a base because if I add an H there, that would have been acid, right? Just replace the Na with an H, and I don't have an acid. So I have a Ka for a base. Does that make sense? No, what is Ka for? Okay, so how do I go from Ka to Kb? Kw equals Ka times Kb. So to solve for Kb, I just take Kw divided by Ka. And what does Kw equal? 14th. And what does Ka equal? Yep, exactly. Tell me what you guys get. Zoomies, how you guys doing? Is following along with you?
Yes. Yeah.
Okay. If you have questions or concerns, please let me know. Cool. So that's going to be our Kb value. I'm going to write it up here so I can just erase all my work right now. But I figured out my Kb value. Good. What is Kb value? What's Kb going to help me solve for? Is Kb going to help me solve for pH or POH? POH, right? So let's use a different color so you guys can see on a different step. So Kb is equal to the same thing, X squared technically over HB if you want to do that, which is a concentration of the base, right? So we have 1.56 times 10 to the negative 10th is equal to X squared. What? Oh, 22, you're good. Okay, what do I do? How do I solve for X? Yep. So we're going to multiply this side and this side by 0.2. That cancels that out, 0.2. And then I'm going to take the square roots. And that should give me X squared. What'd you get?
Over the whole thing.
What did you get for X?
X, I got 3.1. That's the first one.
That's before square rooting. I need the square root. 5.59 times 10 to the negative 6. Okay. Cool. I got 5.56, but it's a very, very small number. It doesn't matter as long as I get the 5 times 10 to the 6 power. That's what I care about. Okay. And again, it is H or OH? It's just OH because I solved for Kb. Now, how do I go from OH to POH? POH equals what? Nope. The negative log. When you're solving for POH, it's the negative log. Remember, this P right here stands for negative log, like pKa, all that stuff. That's just going to be negative log. So negative log of 5.9 times 10 to the negative 6 gives you what for POH? 5.25? Okay. Good. Am I done? No. pH is equal to what? 14 minus POH, which gives you what? 8.75. That was one of the longer problems we're going to do, right? But it tests everything you need to do. It tests how to get Ka, how to get Kb. It tests what it's testing what Kb is testing for. It tells you what Ka is testing for. It tells you how to go from one part of the equation to the other part of the equation. It's a very long question. It won't be on the test like this, but it's a good practice question because it tests multiple things. That make sense? Okay. Okay. Equal volumes of solutions of acetic acid and their sodium salt were prepared to mix a buffer. The solution with a pH closest to 4 was prepared by mixing. So let's circle the things. Let's use a highlight function. Okay. So equal volumes of solutions, that's important, of acids and their sodium salts. Okay. Our mix prepare what? Buffer. pH close to 4. The reason I did that with the buffer is because we're making a buffer. What is the equation for buffer? The Hessen-Hasselbalch equation, which is pH is equal to pKa plus the log of A over HA. So, remember, these are concentrations. So, let's look. Hey, if you look kind of quickly, there's a problem with a lot of these things. First off, look at A. What's the problem with A? We're going to buffer. What's a buffer? It's a weak acid, and it's conjugate base, or a weak base that's conjugate acid. So, two things. They both have to be weak, and it has to be for its conjugate acid and its conjugate base. It can't just be a random one. HCl, strong or weak? NaCl, that's a salt of a strong acid. So A cannot be right because it's a strong acid. Benzoic, formic, butyric. These are things you guys should not know the structure of. This is not organic chemistry yet. That's fine. Are they any of the 6 strong acids you guys learned in class? Hydrochloric, hydrobromic, hydroiodonic, right? Then you had sulfuric acid, and I think you guys only had 5, right? I can't remember the 5th one, right? There's 7? Yeah. Oh, I'm missing 4. Okay, but it's not one of those ones, right? Okay, so they're gonna be weak. Next up, what do you notice about concentration? So if I plug in the same thing here and here, what do I get? Get them 1. What's the log of 1? So what this means is, that's why I said the equal volumes, is that pH equals pKa. You just take the negative log of the Ka values, tell me which one is closest to 4. And it is not, but that's why it was said that it was equal volumes and equal concentrations.
B is 4.2.
Okay, 4.2. Keep going. You want, so test, this is how you do test questions, is especially with higher graduate level tests, is you need to do all of them. Don't just stop when you think you got the right one. Okay, C is 3.3.
And then
4.8. And all we were doing is taking the negative log of the Ka value. Okay, so which one is closest to 4? It is B, right? The reason I want you guys to always finish it out is because you know what happened with the lab final. Things might not always work out. If you can show your work for everything, you'll get easier chance of arguing for bonus points. Also for graduate level tests and higher, they will always make ones really, really close to each other. So always, 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 always do them all. Okay, Zoomies, we good?
yes.
Yeah. So, which pair can make a buffer? Again, what makes up a buffer? Weak acid's conjugate base, or a weak base and its conjugate acid. Good. Solution A. It's a weak base. Is it? You're wrong. Look at it. What's going on between these two? One lost a proton, right? So which one lost the proton? The first one or second one? So the one that had the proton to begin with is technically our acid. This is our base. We're talking about that in a little bit when we talk about Bronsted-Lowry and stuff. Okay. So weak acid, weak base. Let's not stop just there. Let's look at the rest of them. B, is it a buffer? Why not? Well, it's a salt, but what's the problem with NaOH? Strong. No. What about C? Hydrosulfuric acid. Yeah. No. What about D? Hydrobromic acid. So A is the one left over because it's a weak acid, weak base. Does that make sense? So you could solve mathematically which one's the correct one, or conceptually. That's what these two questions are testing. Okay, number 6 is the one we go a little bit in a tangent for, because I want to go over multiple concepts here. So there are multiple ways of looking at the strength of an acid. What are they? How do you look at the strength of an acid?
Isn't it the highest or the Ka?
So what?
Highest Ka is the strongest acid.
So yes, so you're correct. I'm gonna write this down. So an increase in Ka means you have a strong acid. Okay, what other ways can we test the, see how strong a pH is? What else do we look for? Sorry, for an acid, what else do we look for? How many hydrogens, right? So we want a lot of hydrogens, correct? That tells us we have a strong acid. What else? What's another way of looking at the strength of an acid? We did in class a lot. We used the pH meters. So low, that's what I was looking for. A low pH, right? So a low pH means we have a strong acid. Okay, what's the last one? So we got pH, we got H, we got Ka. What do you think we're missing? pKa. So what do you think the trend is going to be? High pKa or low pKa? Look at the relationship between these guys. When you take the negative log, it's the exact opposite. So a low pKa means a strong acid. Does that make sense? That's what I want you guys to know, because when you look at this problem, it could ask for Ka value. It could ask for hydrogen concentration. It could ask for pH. It could ask for pKa. You need to know the difference, how all these relate to each other. And then vice versa. What happens if I have a very, very low Ka value? Do I have a high Kb or low Kb? The lower my Ka, the higher my Kb is. These are always inverse of each other when talking about acids and bases. If I have a high Ka, low Kb. If I have a high Kb, low Ka. If I have a lot of concentration of H's, I have a little bit of OH's. If I have a low pH, I have a high POH. Make sense? If I have a low pKa, I have a high pKb. These are always inverses of each other. Does that make sense? This is being tested because everyone has a hard time understanding how this works, and I want to make sure you guys understand this. Okay, so we are looking for the strongest Ka value. Which one's the strongest Ka value? Good. You guys, also testing you guys to make sure you guys can read scientific notation. A lot of my Chem 113 students still can't read scientific notation, which is very scary. You have to be able to read this. If you have a hard time determining which one is bigger than the other one, come talk to me. I'll give you some examples. Okay. So, Zoomies, you good?
Yep.
Yep. Okay, low pH means what? Acidic means strong acid. So, let's look. Let's do the easy one first. NaOH, strong base. Nope. KCl. It's the salt solution of a strong acid, or the conjugate base of a strong acid. No. So strong acid associated 100%, right? Does that mean their bases are strong or weak? The higher my pH, right? The lower the pH, the higher the pOH. And a low pOH means a strong base, right? So in this chemical thing, what happened here, right, most likely was hydrochloric acid reacting with KOH, which is also a strong base. It's going to go forward, right? So I'll get water plus KCl. Can KCl ever overcome hydrochloric acid and KOH to become back to the hot strong acid? No. If it did, what happens immediately when it forms? It breaks down again. Do you see? So the conjugate acids of strong acids and the conjugate bases of strong acids and the conjugate acids of strong bases are very, very weak because they can't go backwards in the reaction. There's no forward and reverse. There's only a forward. Does that make sense? So be a weak base. Okay. This guy right here. What about him? What do you think? Those guys are no.
Is it HCN? It's another salt.
It's another salt. Yep. So it's a salt, maybe. This guy right here. What do you think? Is he a strong acid? No. It is the lowest because this is the only acid up here. This is a salt or a conjugate base, strong base. That's the only acid up there. And we know it's an acid because you guys should know your polyatomics, my bad. And one of polyatomics is ammonia. When ammonia reacts with, for example, hydrochloric acid, it forms this guy. Okay. Just make some sense? Okay. Now let's talk about Bronsted-Lowry. Okay. So I'm actually going to bring up the whiteboard because we got to talk about this because I don't know how well they went over it in lecture. Okay. What are the 3 ways of looking at acid and bases? So we have Bronsted-Lowry, right? This is called Bronsted, right? And what does Bronsted look at? Transfer of what? Protons, right? Hydrogens. So, for example, if I have, so an acid's going to donate what? Yep, it's going to donate hydrogen. What's a base going to do? It's going to accept. Good. I know I'm misspelling. I'm just trying to go quickly because we have only on 8 out of 50, so we have 42 more to go. Lewis acids and bases. What do they care about? What's the opposite of a proton? No, electron. So Lewis acids are the exact opposite of a Bronsted-Lowry acid. So what's the acid going to do? Accept or donate? It's going to accept, right? Going to be electron acceptor. Acceptor of electron. And then the base is going to donate. They don't go over Lewis. I like going over Lewis because you'll see this in organic chemistry. Because in organic chemistry, you only move electrons. We'll talk about that when you get there in a little bit. Also why is because you can look at acid bases now as redox reactions. Something's gaining electrons, something's losing electrons. That's why I like tying it back in. Lastly, what's the last one? This one's kind of barely covered, but it could be asked. So this is Uranus. You guys cover this one at all or no? Okay, this basically means it's an acid or base reacting with water. So what's special about water? It can be either or, right? It can be an acid or a base. So if I put something in water and it pulls a hydrogen from water, what's that mean? It's more basic than water. So if I know the Ka and Kw of water, which I do at 25 degrees Celsius, right? Because both Ka and Kb both equal 1 times 10 to the negative 7th. So to test something's unknown pH the hard way is I just take it, add water to it, and see what happens. So for this, an acid will give a hydrogen to water and form the acidic water form. The base will take an OH and make OH of water. Okay. I didn't see anyone's claiming this room. Yeah, I know. It's because the end of the semester. I don't know if we're doing anything special, but it's. Huh? Oh, that's probably what they think it's doing. Okay. Oh, good. We need to move. We can move. Okay, but that's what that is. Just makes sense? The reason I'm telling you 3 definitions is because I don't know which ones you asked in the final. All 3 are valid. Most likely, this is the one you guys will see the most on the test. This one could be asked. This one is good to know in case they want to be very cheeky on the test and ask a really random question. Okay. So Bronsted-Lowry, what's being donated? Hydrogen being donated, right? So let's look. Whoops. I got I got how many hydrogen there? I got 5, right? I got 2. I got 6. I got 1. Which of these 2 donated it? The first one donated its hydrogen. It went from 5 hydrogens to 6 hydrogens. This went from 2 hydrogens to 1 hydrogen, right? Yeah, it's what you got to make sure you're hydrogens because Bronsted-Lowry. Yeah, because it's what we've been doing in class. I know. It's the exact opposite. So I'm trying to teach you both ways. So water has to be your first base. I mean, it's half of them. Next up, if this is my acid, what's this one have to be then? That's my base. So I got to look for my conjugate acid, right? And what does the base become? The base becomes the conjugate acid. That's one way of looking at the problem. If that doesn't make sense, it's always confused you, that's fine. Break them apart, look at this. Which one of this guys over here is going to donate a hydrogen? This guy, right? Because you have to make this guy over here true. So here's my acid and here's my acid. The one that has both of them is B. Does that make sense? That's how you look at this one. Okay, moving on, moving on. Okay.
Which one is it?
What? Oh, this,
Which one?
8 was B.
Thank you.
Whoops. There we go. It was B. Okay. What is the pH of a solution formed by mixing 25 milliliters of a 0.5 concentration of NH3 with a 25 milliliter solution of 0.2 M hydrochloric acid. So here's the problem. What am I just asking? Well, the easiest way to tip is look at this. So what do you think NH3 is going to be? It's going to be a base, right? So wink, wink, hint, hint. Ice table. It's an ice table. Yeah, I know. So I'm going to see if I can copy and paste this into my whiteboard because I don't want to go back and forth too often. So let's see if I can do this. Share your screen. Oh, God. Okay, we're going to do text, and hopefully this doesn't screw everything over. Ah, it's not the worst. It's just confusing to look at. I mean, all word problems are a lot of words. Okay. So we're going to do an ice table. And there are two reasons why I know I'm going to do an ice table. One, I'm giving KB, and I'm total salt pH, and I'm adding an acid to a base, right? That's not normal, usually. Second, if you calculate both of them, right, they're at both different concentrations, right? So that's not good, because I can't know the concentration of something if something's at different concentrations. So I need to do an ice table. Oops, that's a gigantic undo. I'm gonna do an ice table, but first, let's draw the reaction out. NH3 will react with this to make NH4Cl. Ice, ice, ice. I'm going to go to the next screen just over here. Actually, I'll just do it in this corner and then erase it later. Okay. Because I got to make sure they're both in the same concentration or same unit somehow, right? So what unit can they both be easily converted into, if not concentration? Moles, because they're already in concentration, right? They're already in molarities. I need to convert it to moles. Problem is, what my volume's at? Liters, right? Milliliters, convert that to liters. So it's 25 divided by 1,000. What? 0.025, right? Liters. So now I'm going to take, let's do red for this guy, and let's do purple for this guy. So I'm going to take my 0.15 moles per liter, and I'm going to multiply by 0.025, cancel liters out. What do I get? 0.037, 0.0037. I get 375. Let's use 375. I'm adding one more decimal point because it's going to make it equal the number we want it to, or very, very close. 0.0037 is fine. 0.004 is okay. I'm just doing it like this. Okay. Next, I'm going to do purple. Now I'm going to take the next one, which is 0.12 moles per liter. And we are going to multiply 0.025 liters. Cancel it out. So it's 0.12 times 0.025. 0.0003. Right? There's two zeros there, correct? 0.003?
Yeah.
Okay, good. So I'm going to erase this work right here because we're going to need more room. Hey, we notice something here. What's this guy? A weak what? What's this guy? Strong acid. What's this guy over here? It's a weak acid, or also known as a conjugate acid. So what this means is, what did I just make? I have a weak base and it's conjugate acid. I'm going to buffer. So I'm going to use the Hess-Hofsbach equation where pH is equal to pKa plus the log of A over HA. So let's do this. So first off, what's my change? What do I subtract what from? So there's two ways of looking at this. Either always subtract the smallest number from the largest number, or if you have a base, subtract the acid. If you have an acid, subtract the base, right? So minus 0.003 minus 0.003. If you subtract over here, you add over here. So I should have 0.0075. 1, 2, 3, right? 1, 2, 3, 4. Did I mess up? Yes, I did. 3 zeros. Sorry. 1, 2, 3, 4. So 7.5 times 10 to the negative fourth moles. And I have over here 0.003 moles. Now, to do this, these guys are in concentration. How do I go from moles to concentration? What do I do? Divide by what volume? Total volume or individual volume? Total volume, because we added these two things together, right? So it's going to change the volume up. So we're technically also diluting these things as well. So what is 0.025 plus 0.025? Because it's basically the same, what we did, is what? So divide both of those guys, I'll use, I don't know, blue. 0.05, 0.05. So you got 0.06, okay? And for 0.015, got it, okay. I have it switched? Whoops. It's all good. So this right here is the 0.015. And then this is the 0.06. Okay, good. Am I ready to plug it in now? Plug and chug or no? Nope. What's given to me? KB. So I can proceed forward and solve for POH using PKB plus the log. I just got to flip them around, right? Or I can just take KB and turn it into Ka by taking one, oh, I'm sorry, I'm gonna change colors for you guys. What's an ugly color we can do? It's too, nah, brown's okay. Let's, what, you don't like brown? Why you guys don't like brown? What's an ugly color? Okay, you guys said it, not me. I didn't mean it like that. Some people like the color brown. You guys would not survive in the 80s at all. Oh, sorry, the 70s. 70s, everything was brown. And I know it because my grandma lived through that, and her entire house is a brownish color. No, it's not. It's bad. Because she's also a hoarder. And a crazy cat lady. So there's a lot of things. So what'd you get for Ka? 5.56 times 10 to the negative 10th. Okay. So now what I do is make that pKa by taking the negative log of it. So what'd you get? So much color. It's gonna look so much like fun. We haven't done this light blue. Let's do this light blue. So what's pKa equal? Ugh. 9.25. 9.25. So we're going to have 9.25 plus the log of what? A. What's A going to stand for? We just converted it Ka. That's what this right here, that's what the brown thing was for. So which one's up top? The acid or the base? Does this guy have an A? The base is up first. 0.015, 0.06. So, oops, 0.015 divided by 0.06. Good, that log of that's good. 9.25 plus that number. What did you guys get? 8.6. Let's go see if all our hard work was correct. Whoops, Madison, you're on screen. Sorry, I apologize. Okay, you're gonna be on the people's camera for like 3 seconds. Okay, there we go. 8.6. Okay. It's fine. I'm glad we're going back to in person. Getting on Zoom calls with people was very concerning, especially when you guys first started the semester. The things I would see in people's screen when they shared the screens was not good. It was mainly guys. I'm not gonna call people out, but the things I saw on the screens, things I didn't need to see. Also, roommates walking around, it would have been nice if they had actually had like pants on sometimes too.
There was one chemistry lecture where some guy was on the thing and his roommate and started undressing. And I was like, can you stop
Yeah.
this? We're learning chemistry.
Yep, it's interesting, isn't it? Be fun if it was anatomy though.
Oh.
Good. Make some jokes. Okay. Calcium hydroxide is slightly soluble in water. Oh no. KSP is what? Solubility constant. What is the pH of saturated calcium hydroxide? Oh no. So this is everyone's favorite question in which you're testing multiple concepts. The question is convoluted. KSP only cares about what? Products or reactants? So if I have, for example, like salts, and I put that in water, what happens to it? Dissociates. I use the products of that to calculate KSP. Because KSP doesn't, we don't care about solids, right? And what's the only thing that can dissolve in liquids or solids? If I add a liquid to a liquid, does it dissolve it? No, I just dilute it, right? If I take a gas and force it into a liquid, does it dissolve? Usually not, right? It's just trapped in there under pressure. So the only thing we have in as reactants is usually solids. We don't use those. So KSP is always going to be the concentrations of the reactants multiplied by each other. Okay, up next, calcium hydroxide. What the hell is that? CaOH? Wrong. OH2. Remember, periodic table, calcium has a charge of +2. OH has a charge of -1. We need 2 hydroxides to appease it. I know, but it's very important because they're going to ask you questions like this on the test. Well, not exactly at number 10, because as you'll see, it gets very convoluted. Okay, so KSP is equal to the concentration of Ca times the concentration of OH squared. Now, since I'm not given the concentration of either Ca or OH, this is where you combine them together, right? And you'll get X times 2X squared, and you'll get 4X cubed. So now we just got to plug in our KSP. So 1.3 times 10 to the negative 6. So how do I solve for X? What do I have to do? So I'm going to divide by 4. Then what? Take the cube root. And I got X. Does that make sense? We're solving for X because we're given KSP. We're looking for the concentration of calcium hydroxide. Look for the concentration of this guy. So what does X equal after doing all that work? Yay, emails. Ugh. 0.069. Let's round that up to me real quick. To what? 0.007. The reason I'm doing this is for an easy way. You'll see why I rounded it up. Okay, that is the concentration for calcium hydroxide. How does the concentration of calcium hydroxide help me find pH? Negative log? That's correct, but there's one more step beforehand. How many OHs do I have? So what do? I multiply this 0.007 by 2, and it easily becomes what? 0.014. That's why I rounded up so I could do math. I could do mental math much easier.
And that's because there's 2 hydrogens in the calcium hydroxide.
Because there's 2 OHs. For every one concentration I have of CaOH2, I have to have double the amount of OH molecules in solution. That's why I double by 2. Well, here's the thing. I have that's just the concentration of OH. I'm looking for pH. So what do? Negative log gives you POH. Yes. Again, also why I made it 7:14 is to confuse you guys so you guys slow down and look at stuff. I know I usually make things easier, but I made things a bit harder this time because I want you guys to slow down and see that sometimes they'll give you numbers that are so similar that you might just instinctually do something. So what's the POH? 1.85. Good. How do I find pH? So pH is equal to 14 minus 1.85. What'd you guys get? Closest one to it is 12.14. You see? 1 like 10 will be on there because it takes way too long to do, right? Because you guys only have about 90 minutes to do the test. So number 10 won't be on it, but it's just testing you guys. You can be given KSP, you can find pH. Okay. Oh, real quick, all the emails been getting. When you email me about your grades, please make sure, I'm talking to everyone, even people on Zoom and people who are watching this video, please make sure when you ask about your grades, you word the email very carefully. Do not ask me what I can do to get an A. That is wrong for 2 reasons. That puts me in an uncomfortable position because if I can't, I'm not going to manipulate your grade to make you get an A. Also, GCU is not like 75% females. I'm a male teacher. That puts me in a Title IX violation if the email could be construed in a weird way. So please make sure you word the emails very carefully. I had to ask a bunch of people to reword the email very carefully because it could be bad. Luckily, GC has never had that issue before that I know of, but other schools have had that issue. And that's just very uncomfortable though, because I don't want to go out and have a timeline violation because then I could be fired as an adjunct because what can I do to get an A? It's like what can I what are some ways I can improve my grade or get my grade up?
We can say that, or we can say
Yes, because that's different because you're like demanding an A compared to like an improvement of a grade. It's just the way it's worded.
what can we do next?
Educate. If you want to be super safe, educational wise is fine. It's just make sure that it can be read differently because I'm a male professor. I know most of it isn't cross your mind, but it's just something I have to be worried about, and I do overtraining for it. And just very careful. Just make sure you word it very carefully. It might be, and also I might feel weirder because I'm closer to your guys' age and most of the other professors are. So it could be even taken worse because I am closer to your guys' age. So yeah, it's weird. So make sure no one's uncomfortable and no one gets in trouble if something does occur. Because all the emails you send with the GCU email are tracked by the school.
So all those emails when they ask me like, what do I do here? They get.
They can look at it. It's recorded. Hey.
Do you get in trouble if you email past a certain hour?
No. I just gotta respond. And then watch. I just got an email. Hey. Nice. The email I just talked about just got one just like it. Nice. Hopefully watch the video that you understand. Okay. Okay, so now we're doing number 11. A 0.100 molar concentration of a weak monoprotic acid is 3.5 ionized. What is the pH of this? So number 11, I'm going to use a really weird formula. This right here will not be on the test. You are not taught how to solve for this one like this. This is adding a bunch of weird concentration concepts together. So the first thing you want to do is take that 3.5 and convert that into a whole number. Right? How do I go from percentage to a whole number? What do I do? Yeah, divide by 100. Right? So that guy becomes 0.035. Okay. That's good. Up next, what I'm going to do, and again, this one's not going to make sense. I'm going to show you guys how to solve for it. You guys show work, but the way I'm going about it is not taught to you guys in lecture class. Because it won't be on the test. Because it's way to go about it, it's really weird. You solve for Ka, we're going to multiply this by 0.035 squared. So it's 0.1, which came from here. I square the number I just got from that. So 0.1 times 0.035 squared. And I get something akin to 1.225 times 10 to the negative fourth power. That's my Ka. Now that I have Ka, here's the weird one we're going to use. We're going to use pH is equal to 1/2 pKa minus the log of HA. You weren't taught to do this one. That's why I'm going to do it this way, because it's the only way to do it.
Isn't pH normally equal to pK?
Only at equal concentrations, which they are not. So take the negative log of that number. So the negative log of that. So it's fine if you guys understand this one. This one will not be asked. Minus the negative log of 0.5 That would give me minus 0.3, which gives me something akin to 3.6 divided by 1/2. pH is close to 3.91, yep. Mm-hmm. At 1.7? That's one of the answers, yes. pKa, 1/2 of pKa minus the log of HA equals 3.91 minus. Good. 3.91 minus that number gives me that. That got divided by 2. I got 1.8. What's the closest one to that is B. So the answer would be B. What'd you get? Okay.
Wait, what did you get for the HA?
HA is going to be this guy right here. It's fine if that one doesn't make sense. You weren't taught how to solve that one. It's weird. What? Had that one on the practice quiz?
Is that the same as percent ionization?
No.
It's not?
It's asking something way different. I don't think we did the 1/2 pKa that. This is using percent ionization to find pH. It's a bit different. I don't think we asked a question like this. Huh? It was B, yes. The reason I don't think we asked a question like this is because this is testing the idea what all these words mean. It just takes way too long to figure it out. If I didn't give the formula, you have to derive it from things, and it's very annoying. Okay. That's only one. Yeah. That's why I want to kind of move on too, because we still got some more to go. Okay. So, which of these is the weakest? Hydrobromic acid, strong or weak? For 12? You're wrong. Yeah. Okay, you go study for that. Yep. Strong, weak. So the weakest acid would be the weakest acid. So.
I was looking at the pHs for all of them, and it told me that the HCl had a lower pH.
Which means it's a stronger acid. See, that's why you have to be very careful when you do these things. You got to slow down and like remember that what I drew up there.
We're not giving them time to slow down.
I know. That's why you got to beat it into your brain while studying. Okay. Oh no. So when I talk about species, this means it's going to individual one. So now we're talking about oxidation reduction. This is the electrochemistry. This is also a concept from 113 as well. So the agent is there. What does that mean? It means the opposite. So what's the opposite of reducing? I'm looking for the oxidizer. Anytime you see agent, you're just looking for the exact opposite thing. Okay, so out of this, what is being oxidized, what's being reduced? Let's actually look for what's being reduced. That's much easier to see, in my opinion, than not. So when something is reduced, what does that mean? You go up or down a number? It goes reduced, it goes down a number. Here's a positive thing. Did it go up or down? It went from +3 to 0. Went down. These are being reduced. Which means what? This is being oxidized. Right? Oxidized. No. Don't worry about the reactants when dealing with oxidation numbers. With oxidation. Always deal with the products. Okay, so I circled this one as the right answer. So in oxidation reduction, you only care about reactants, not the products. because the reactants are what pushes it forward. If you notice, what direction is the arrow facing? It only forces in one direction, right? So you assume there is no counter direction, right? So this is only that can react. So that's the only oxidation and reduction that can occur. Does that make sense? Okay. Please not confuse agents with conjugates. They're different. Hey, galvanic cell. What's that mean? It means a battery, right? We mean in chem lab. Okay. Uh-oh, we have a cathode half reaction. What happens in the cathode? Reduction. So what happens in the anode? So I already have half of my reaction, right? So I just take out the half I don't want. And I should have the anode half. Does that make sense? So should the anode have anything to do with magnesium oxide? So B is wrong. Because it has that in there, right? Okay. Second, if you look, besides the water, right, and hydrogens and the electrons, do I have any numbers in front of my magnesium? So half reactions do not have numbers there. 14 is C. They don't have numbers in there until you combine them together. Because that's how you make them equal each other.
But when you multiply,
you have to make them equal each other. Yes. Because what this is saying is, when you look at a half reaction, you have to remember that this is what scientists see, right? They're seeing, okay, magnesium's reacting in some type of watery solution, right? So it's going to make this many electrons, make this many protons to form this over here. Does that make sense? That's what they're looking at. Yeah. And it's always usually cathode has the longer half reaction because it's going to be doing way more stuff than the anode is, usually speaking. Okay, 15. So, equilibrium constant. But I'm giving you standard potential. So what does this mean we have to use? The equation you guys are using for the exam you guys have next, quiz you have tomorrow, right? So E equals E naught. Is it at 25 degrees Celsius? Then yes. 0.592 N ln of K.
Would it be minus?
Yes, it's minus. There's a negative there. So E naught is equal to 0.592 over N. Yes, you're correct. Sorry. Again, I'm finger painting with my hand. It's very hard to write neatly. Okay. Is it? This one's a bit different. When you look at the, okay. You're also going to use log then if we're going to use this one, because it changes. Okay. We were on 15. Okay. But just trust me in this that you're gonna use E naught to solve for, right? Because there is an equation that's just like this where you assume that the energy is going to equal E naught. Well, you can assume this at most times because we're solving for ln of K, or solving for the log of K, right? So we have to solve for something. Okay. Hey, we're given this. Good, we don't have to solve it. So no hijinks like last time. 0.47 is equal to 0.0592 over N ln of K. Sorry, not ln, log, 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 not ln. If you use this version, you have to use log. No, we're going to do it this way because we're not given an E value. So we just assume that E naught equals E. You can assume that, yes. If you're not given an E value and you're told to use this equation, you can assume that E equals E naught. Because we're going to assume that it's not going to be a very, it's going to make sense. Okay. Okay. So how many electrons are being transferred? So what does N become? So 0.0592 divided by 2, right? That becomes a whole number. And then you're just going to divide that, put that number here. I got 0.0296. Is that what you guys got too? Which gives you 7? I got 15.9. Okay, so log of K or Q is equal to this. How do I get rid of log? Big ass number. C. So when you're dealing with numbers that big and that small, it doesn't matter as long as you have the first number right and the exponent right on the base 10, because it's such a huge number that it doesn't matter what's in between. That makes sense? Okay. Because when you're dealing with these really big and small numbers, a simple rounding issue can change the entire thing. Hey, 16. Now we're looking for standard cell potential, which means what? Yep. So the energy of the cathode, or whatever is being reduced, minus the energy of the anode, or whatever is being oxidized. Oh, can we tell what's going on here? Yes, they were nice and gave us the equation. Is it? Is it being reduced or not? Yeah. So 0.44 minus negative 0.76 plus. What do you get? It's pretty easy because you have to get a positive number, right? So I eliminate all of them. The reason why all the answers are negative, or except D technically, is to trick you. You have to go cathode minus anode, or reduction minus oxidation. Okay, under what conditions is the Nernst equation used to calculate the cell potential? My lab students, what did I tell you to do when you did this? To cry. I didn't tell you to cry. You guys cried anyway. I told you to wait until the machine told you to stop changing numbers, right? Because the Nernst equation only works at equilibrium, right? We can only use these numbers once we said all the electrons have been transferred. If I stop at mid-reaction, are all the electrons transferred? Do you get a full oxidation reduction reaction? Then I didn't really truly get it. I can't use the Nernst equation for that. Does that make sense?
So is that why there's a constant?
Yes. Also, non-standard concentrations. What's a non-standard concentration? That doesn't make any sense, right? There are no standard concentrations. Concentrations just vary. So we like when batteries are non-spontaneous, right? However, if you can make a spontaneous battery It just tends to draw energy. It's how your phone charges from the wall socket. It pulls the energy, right? And you can actually make a battery that you can put electricity into a wall socket. It's called an EMP. Okay. So reaction of ions of the same charge. We've only seen this happen because it's easy, but we can have something be reduced by 1 and something be oxidized by 2. It just, you have to balance it out. So that's why the answer has to be C. Zoomies, we still here?
Yep.
Okay, making sure. I lose Zoomies pretty easily. I know it's kind of tedious to go through all this. Okay. So, what's the following is true for electrochemical cell based on the electrochemical reaction? If K is less than 1. So what does K equal, guys? Good, you guys remember this. See, that's why I beat into your heads, you guys know. So, if K is less than 1, what does this mean? If K is less than 1, what does this mean? It favors reactants. Reactants are high, products are low, K is small. Is K negative? Could it be negative? K can never be negative, no. But it makes it easy to assume that K is negative for certain things. So, we're looking at delta G and E naught. Well, luckily, there is one equation, right, that uses both of them, and that is delta G is equal to negative RT ln of K, and delta G is equal to EF naught. Sorry, NF naught, E naught. These equations should look familiar. We've used them before. Okay. What? Negative what? No, it's just, I think it's just N. Oh, it is negative 9, you're correct. We are 18. It is a negative N. Thank you. I missed that in my notes, that's why I was confused with this one. Okay. So, let's say, for example, I take the ln of, give me a number less than 1. Okay, 0.2. The ln of 0.2 gives me a negative number. Because the ln of small numbers are always negative. So, this is negative. It can be any small number as long as less than 1. It will be negative. I am going to multiply that by a negative number. What does G have to be? Spontaneous or non-spontaneous? Non-spontaneous, right? Because when delta G is negative, it's spontaneous. Things happen randomly. Good. Okay. Now, I plug in a positive delta G in for here, right? I solve for E naught. E naught is equal to delta G, which is positive, right? Divided by NF, which is negative. So what does E have to be? Here's a cool thing to look at this. You guys can notice now on. Delta G and E have to be opposite signs. Because a galvanic cell that is working properly is spontaneous. Electrons will go from cathode to the anode, right? Which means you should get an energy out of it. You should get a battery charge out of it, correct? Which means you're getting a flow of electrons, which means you could tap that electrons and get energy. If it was working the opposite way, you're pulling energy from somewhere, right? You would get a negative E, right? Which means you're getting a negative E, which means the battery is absorbing energy, right? Which is not normal, which means delta G has to be the exact opposite, so non-spontaneous. Does that make sense? So they are always opposites of each other's. Okay. 19. What do you think?
I put A. Because the electrons always go that way.
Yes. So based off the information given, it is A. I spent 30 minutes on this question because there's reasons why you could argue B, it's a bad question, but choose A because you're not getting any other information besides that. No, it's because of the oxidation potentials of silver and zinc. Zinc technically has more oxidation potential, right? Sorry. Silver has more oxidation potential. It wants to be oxidized more, so it could theoretically pull the electrons and make B correct. But because of all of the things you've ever seen before, A is the correct answer. They wouldn't do that to you. It'd be kind of fucked up to do without giving you values to double check.
I mean, don't you think though, the person who writes this wouldn't do that?
No, because 20 is testing the next concept. So, what's going on here? Yeah, they are. But what's going on in these half reactions? They're both reduced. Okay, so these are the energies of reduction. I'm looking for the reducing agent, which means I'm looking for what actually? The oxidizer. Just given these numbers, which one is the oxidizer? Which one's the reducer? Here's how you figure it out. The biggest number is the strongest reducer, right? So which one is stronger? Negative 0.13 or negative 0.44? This number's bigger, right? Which means, without knowing anything else, I can assume this is the reducer. That means this guy up here has to be the oxidizer. Does that make sense?
So then which would you choose after? Would you do E to
Again, this one, you would do, you don't do the those ones, right? Because it's being reduced. Sorry, it's being oxidized, right? So it starts off in its neutral form. It has to lose electrons. So it has to become Fe+. Does that make sense? What's up, Athena?
So are you saying that because you have to?
So if you write the chemical equation out, right, I have to start off with neutral iron, right? And it has to react with the lead counterpart to make iron 3+. Hey, also look at, we have a cell with different amounts of electrons being exchanged. Another way to prove my point that it has to be equilibrium. Yeah. Which of the following statements is true about equilibrium of any reaction? Hey, hint, hint, wink, wink. You're a Friday student. Hint, hint, wink, wink. By the time you watch this video, get this far, most likely it's already gonna be Friday, so it doesn't matter. But this was asked during your guys' lab final, wasn't it? What did you guys put? Yes, you're correct. Athena, what'd you put? Okay, yeah, then do you have comments about it? We can go over it again. What's up?
I just thought the lower the number, that's the reducing.
Okay, the lower the number, right, you're closer to 0, which means you're more powerful. You're more negative? Which one's more negative? Yeah, which means it's a shitty reducer, right? Because the bigger the number, the better reducer you are. Correct? That'd be the oxidizer because it's a shitty reducer.
Right.
Yeah, that's why, and it's a reducing agent. When I'm looking for the oxides, I'm looking for the thing being oxidized, which would be iron. Make sense? Okay. So the answer is B. Well, why? The concentration of the products and reactants are the same? Is that true? No. You could sometimes have different concentrations, right? The equilibrium Kc is defined by one equilibrium concentration, by only one. Can you find Kc just by one of the concentrations? No. Products Overreactance, good. Does the reaction ever stop at equilibrium? No, it's always going back and forth. It's fighting. That's why B is the answer. Okay. Okay, so 22 is testing an interesting concept. What two states of matter do we not care about? We don't care. We don't care. Now, this one actually is correct, unlike Monday Labs one. So, get rid of it. Which one is products over reactants? Because the products are ones I don't care about. They're both a solid and a liquid, right? So if I get rid of them, this one I have right here. Does that make sense? I don't include them, right? So I just don't include them. Boom. Also, of note, you need to know what's special about oxygen. So what's special about oxygen, guys? What's special with this oxygen molecule right here? Well, it's an oxygen. What state of matter is it? So can I have concentration of a gas? Not really. It can have pressure of a gas, right? So if you have a gas, you have to do partial pressure. You can't do concentration. You have to do partial pressure. So you can only do Kp of gases. You can only do Kc of aqueous solutions, because that's the definition of concentration, is something dissolved in water. Okay. You notice a lot of these are going really quickly because they're conceptual based questions. Okay. At 25 degrees Celsius, K is this. If the partial pressure of N2 is this, H is this, and H3 is this, the state is what? Which means if I have K and I'm asked to solve for something, I'm solving for Q. And I compare Q to K. Does this make sense? So, and what does Q equal? Q equals the exact same thing as K. Products over reactants. So my product is, technically I'm not going to use brackets because these are gases. I'm going to use parentheses. So 1 squared over 0.1, and then, well, 2.5 times 10 to the negative second, and that is cubed. So what does Q equal? Someone tell me what Q equals. Huh? It should be a big number. What did you get? Or 6.4 times 10 to the 5th. Okay, now I have Q. I compare it to my K value. So this is where you look at this. If Q and K equal each other, what's going on? Equilibrium. Well, does my Q and K equal each other? No. Okay, so which one's bigger, Q or K? So why is my Q bigger? Q equals products of reactants, right? What can explain why Q is bigger? Yep, so let's just draw that out. If products go up, Q go up. If reactants go down, Q go up. So it's not an equilibrium. And did I produce more products or reactants? What do you think? I produce more products. It's going to be B. Now, here's where they can kind of trip you up and ask you another conceptual question, and I'm going to use this as a base off of. What is Q going to do to shift towards equilibrium? Favor products or reactants? It's going to favor reactants, right? So to get to equilibrium, it's going to go the opposite direction to get to equal Q. Does that make sense? Okay. You guys look done already. Got one more week, man. It's only like, do you guys have felt Friday or Thursday? Ew. Ew. Okay. You see on all your exams Friday.
I have 2 exams Thursday.
All of them? How many classes? See, when I was a student here my freshman year, we had all our tests in one day. Lab and lecture.
Are you serious?
Yeah. They why? Because they didn't think about that and it was stupid and everyone suffered. So, well, I had all my, so like, not all my labs, but like say for example, I had a Friday lab and all my tests were on Friday. I had to take the final the same week as all my lecture finals because lab gets out a week early. That didn't happen in my freshman year. That was implemented my junior year. They just realized it sucked, so they made you take the final a week early and just made it like a free week, which they just took away because it was useless. So, yeah, it's great. Okay. So 25, what's going on here? We're on 24? Okay, we're on 24. So, uh-oh, I'm dealing with this thing right here. What is delta H? Change in heat, right? Change in enthalpy if you want to say that. Or change in heat. Much, much easier. It is negative. Exothermic or endothermic? Exothermic. Is it on the product side or reactant side? Heat is being released, which means it has to be on the product side. So we're going to add in heat, right? So now we can assume this is our chemical equation because we have heat in there now. Now, if I decrease heat, heat is part of the chemical equation now. So if I take away heat, what's going on? How does it shift? Shift towards the left, right? Which means it shift towards the products, correct? So it shifts towards the left. Huh? Sorry. No, it's going to shift this direction. My bad. To the right. My bad. Sorry. Yeah. The heat's on the product side. And if I take away heat, I'm basically taking away heat. It's going to shift to make the heat come back. You treat heat like a thing, so it's going to shift towards the right, not left. It's been a long day for me. Okay. So it's going to shift towards the right. Okay, if I shift towards the right, make more products. Does K get bigger or smaller? Okay. So, the answer is C. Okay. 25. As an so the decomposition of NaCl has an equilibrium constant of that. When sodium is added to the reaction, the vessel scavenged chlorine gas in an exothermic reaction. What is the impact of adding sodium be on the equilibrium? So the key word on this is scavenges chlorine gas. So if I add sodium, it's going to scavenge chlorine gas. What does that mean? It's going to eat it. It's going to react with it. So if I add sodium, chlorine gas is getting reacted with, which means it's being taken away. So I take chlorine gas, your phone dropped. If I take chlorine gas away, how is Le Chatelier's principle say it's going to react? And for this side, I took the thing away, right? So shift towards, right? Shift towards the products. 25 is A.
How do you know to use Le Chatelier's principle?
If you're ever messing with a chemical equation, you're going to use Le Chatelier's principle. Also, you look at the answers, and it will tell you use Le Chatelier's principle. So if you use the word shift or favor products and reactants, then you kind of know which one you're looking for. Okay. Okay, 26 is a bit weird. I don't like it, but we're going to deal with it. So the reaction below is exothermic. So if I tell your reaction is exothermic, endothermic, you need to enter in yourself where heat goes. And heat's going to go in the product side. So what happens, what change will I see if I increase the amounts of, if I increase the amount of moles of the phosphate chloride gas? Well, it has to keep up, right? So Yes. So what's going to happen is it's going to shift this way in favor of reactants. But how do I shift? How do I make reactants? What do I have to do? I have to consume my products to make reactants, right? And I'm adding PCl5, right? So I won't lose any because I added some, right? So what's going to go down instead? Heat's going to go down, right? And that's why the reaction is B, because I need to use heat to force it in the other direction. Because if a reaction is exothermic, if it goes the opposite direction, it will become endothermic. And also, if this makes no sense to you, Athena, look at this. So if it's going to shift in this direction, right? What do these make sense? How would that affect volume in the container? That wouldn't affect volume in the container, right? So A makes no sense, right? Krypton gas doesn't do anything. So some of the Cl is being removed. I'm shifting towards a reactant. I'm not going to remove Cl gas, right? I'm going to be making Cl gas. No, krypton is going to be Kr. Krypton's an elemental thing. That's why you can figure it out like that, or think about if I go this way, these guys have to go down, which means that heat has to go down and get used up, which means I get colder. Zoomies, you still here? Oh, you're still with me. Most Zoomies ran away. Okay. I kind of skipped 27. I didn't write all the answers down because it was very annoying. But what you have to do is you have to manipulate the reactions to get these guys up here. Well, first off, is that in the correct position? I have to add both these guys up to get to this guy up here. So what do I have to do to X? So first off, is that in the correct position? Yes or no? It has to be flipped. To flip it, I take the inverse. I'm going to take the inverse. I'm going to do 1/2 inverse, right? Short R notation, right? Okay. I took the inverse. So now it's going to be 1/x now, right? Yep. Yes, I know. So I don't like this one. Next, is this correct? No, because I need to get it to a whole number. How do I get this guy to a whole number? I multiply by 2. Or I'm going to do what? Yes. Yes, you're going to square it. Not one that's complicated. Right? Then if I square this, I also have to square this one because I need to make sure that those guys cancel out and I get a whole number and I get 2 here, which means the answer is B for 27. You could argue A. Yes, but I would put this one right here because you have to square your numbers and putting it in. Because they could be different values. That make sense? Yeah. That's how you do that one. It's very annoying. Hey, solubility. This is back to a 113 concept and kind of a 115 concept we went over very quickly, very beginning of class. So, what are some? So first off, water, polar and nonpolar. Water is polar. So what is the only thing that can dissolve in water? Non-polar molecules or polar molecules? Light dissolves light. So polar has to dissolve polar. If I put non-polar with polar, nothing happens, right? It kind of floats on top of it, oil and water. So how do I get polarity? I have to add something to it, right? This is kind of getting to organic chemistry. To add polarity, you need to have something, you need to have like an ionic solution, or you need to have ionic hydrogen. What's when gas bonds with gas? What's that called? When a gas molecule bonds with a gas molecule. No, London's everything. Come on. Come on, guys. No, ionic hydrogens with oxygen, neon, and fluorine, right? Huh? Nitrogen bonds with, hydrogen bonds are a type of polar bonds. Ionic are a type of polar bonds. There's polar and nonpolar covalent bonds. That's what I was looking for, covalent. Right? So there are, there's 8 types of nonpolar covalent bonds. What are they? They are the 7 diatomics, have no fear of ice cold beer. So those would be, have no fear of ice cold beer. But there is one more, and that is when you just have hydrogen and carbon together. Those of you who are anatomy students, if I have a chain of these molecules together, what is that? It's a lipid. It's a fat molecule. So you need to have ionic bonds, hydrogen bonds, covalent bonds to be soluble in water, right? You can't have London in non-polar because those won't dissolve in water. Does that make sense? Because they're not polar. So that's just CH, right? It's CH, 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 CH. It's all there. There is no oxygen, there is no nitrogen, there is no heavy electronegative ion there to become polar. That makes sense? That's why C is gone. Up next. This is everyone's favorite thing ever. A college student's best friend. I mean, that could work too, but how about an ASU student's best friend? How about that? It's ethanol, which is alcohol. I mean, yeah, but that's ethanol. So, alcohol. Those of you who are old enough to drink, if you mix alcohol and water, what happens? Does the alcohol sit on top of the water, or do they mix up together? Okay, don't legally answer it. I can drink, but they mix pretty well, right? Good. I know that because we do it in lab. You'll do it in organic chemistry lab. You will use ethanol. We'll use pure ethanol. Do not drink pure ethanol because you will die. It's basically moonshine. Do not do it. My family or my great-grandfather was a moonshiner. He blew up in his cabin, so. No, moonshine's illegal because of prohibition. Yeah, you got a backwater chemist making moonshine in the hills and just blew up. So that's fun. Yeah, that's great. So, O, OH, OH. So all of these are polar. So we got to look at what next. Larger molecules tend to be less polar because there's more stuff to kind of interact with the OHs. Does that make sense? Because there's more non-polar regions to fight the polar region. Correct? Especially here. You have non-polar, oxygen, which is polar, and then a non-polar region. The non-polar region is kind of trapped, right? Has a hard time to interact with water. So no. Here, you have one nonpolar to one polar, 3 nonpolars to one polar, right? So methanol is the most polar or most soluble in water. Does that make sense? Okay. Which pair of the compounds will form hydrogen bonds with each other? So what's a hydrogen bond? Hydrogen has to bond with nitrogen, fluorine, or oxygen. So let's look. If A if C4H10 and hydrochloric acid, if those came together and formed, would they both form hydrogen bonds with each other? Yes or no? No. One hydrogen bond would form, but that's it, right? So no. What about over here? Well, yes, but those has a chlorine, so no. Same thing with this. The answer is D, because those two oxygen and hydrogen molecules will form, sorry, the answer is C, not D, will form with each other. Does that make sense? Because they need to form with each other, right? So what over here can offer a hydrogen bond with? Like this will form a hydrogen bond with this, correct? Because the fluorine's there. But how can this form a hydrogen bond with this guy? C, sorry, D is not right. C is right. Because how could, there's nothing for the hydrogen bond to form over this side. But over here, we have two O's which they can kind of connect to.
So the hydrogen always come first.
Yes. London dispersion forces. So London dispersion is what? The strongest or weakest? The weakest. And it only appears on what type of molecule? It appears in all molecules. We only can notice it with non-polar molecules. Because either you have ionic bonds, which are strong enough we can test, hydrogen bonds which are strong enough we can test, covalent bonds which are strong enough we can test, right? So if we get a non-polar molecule, we can test some dispersion forces on it. We know it's London. That's the only thing available to it. Make sense? Okay. So which one of these molecules is non-polar?
Would non-polar be the opposite of polar, but it would bond with the longer chain?
No, just kinda. I would just look at what it's bonded to. So this guy is C polar. Has an OH molecule on it, right? So it has hydrogen bonding, correct? Polar. What's going on here? Hydrogen bonding, polar. What's going on here? It's got a little hydrogen bonding, or you got oxygen there, right? So it's a little bit polar. A has nothing. It's just carbon, hydrogen, non-polar.
Would they really put 33 on there?
No,
Yeah, it's the same.
they won't. 31, boiling point. So it's gonna boil. What do you usually boil? So if something is dissolvable in water, do you think it boils easier? Yeah, right? Because try boiling the oil inside of water. It won't work, right? You'll boil the water first before you start boiling the oil, correct? So so the highest boiling point is gonna be the thing that's the most polar, right? So out of these guys right here, what is the most polar? Water. Water is also it because water has the highest boiling point. That's why we use it. That's why we use it for lots of calorimeters. Water has the highest boiling point of all chemicals. For its size and shape. For your guys' chemistry, yes. But like there's proteins that have a higher boiling point, but they're gigantic compared to water. Because water only weighs 18 grams per mole, right? The proteins I'm talking about weigh 2,000 grams per mole. It's a much, much bigger difference, right? Okay, so what comes next? Which one of these guys is polar, which one of these is not polar?
So is it increasing IMF?
IMF, yes. Yep. So what has the next high IMF after water? Dipole? Dipole? Nope, it's this guy. What's going on with this guy right here? Hydrogen bonds, right? The answer is B. Yep, which occurs with, well, these guys don't even have dipoles. These are non-covalent, so there's no dipoles here. But bigger molecules boil slower than smaller molecules, which should make sense, right? It takes a long, yes, because you got to break each one apart. That kind of make sense? So you cut things up to cook things faster.
Would they also freeze slower?
They would freeze slower too, yes. If that doesn't make sense, well, how size affects boiling point, think of cooking a carrot. Do you throw an entire carrot into a stew, or do you cut the carrot into pieces to throw it in? You cut it up, right? You can't throw an entire carrot in, it's kind of weird. Okay. So this one is weird. So if you notice, we had fluorine, chlorine, bromine, and iodine. So we're only dealing with noble gases, right? So we can't look at chemical properties because they're all the same, right? What's the only difference between fluorine, chlorine, bromine, and iodine? Their weight or their size. Which one's the smallest? Which one's the largest? Which one do you think boils faster? Because it's smaller, right? Which one boils the slowest? Because it's the biggest. And that's what you have to know, that's what you have to look at.
So then by highest boiling point.
Under standard condition, it has to be the one with the biggest one, which is iodine. So 33, don't worry about it too much. But hexane, is it polar or non-polar? You guys did your solubility lab on this one. Or you guys did the whole scenario with the TLC plates? All right. Hexane is non-polar. Which one of these molecules is non-polar? Can't be this guy's got an oxygen. Can't be that guy has an oxygen. Can't be that guy has an oxygen. C is the only one with no oxygens, or nitrogens, or fluorines, or bromines. Do you see that? Because it has no electronegative ions, it's nonpolar. And for those who are taking organic chemistry next semester, this is what you have to draw. You got to count like 1, 2, 3, 4, which means it's butane, and then it's 3-methylbutane. Woohoo! 1, 2, 3, 4, right? So that's the longest carbon chain, which tells you that's the name of it. So butane means 4, right? But right here I have a side chain, right? So I have to tell you it has a side chain on it. So I have to go, oh, the side chain's on 3, right? But it's saying besides going, hey, this is butane with a side chain of 3, I go, side chain 3 butane. Because chemists talk weird. Basically, the higher you go up in education, the more chemists make things confusing so they can sound smart. I'm not lying. Go talk to Grubbs. He's full of himself. He is. He's a very smart man. He's a very, very smart man. But he is a little full of himself. He's not going to see it. You think Grubbs is going to watch a 3-hour Gen Chem video?
He might.
No, he won't. You think he has 3 hours of life? He runs marathons. He's a healthy dude. Man's a healthy dude. If he's sitting here watching 3 hours of this,
You can get the treadmill watching this.
I don't know how you do that. Kinda. It's kind of puzzle solving. I think here it's a bit more. I don't like it here because Grubbs does it. No, honestly, Grubbs does it on purpose. He likes the fact that it's hard. For 34? Okay. Smith's good. Smith's nice. The problem is, Smith isn't, I don't think he's the head.
I actually talked to Dale about this. He said to take Smith because Grubbs talks really smart. That's what he said.
Yeah, he does. Grubbs talks very smart. Grubbs will challenge you, which is good. Smith will break it down and make time with you. But the problem is Grubbs still writes the tests. But Smith will prepare you for the test. but grubs might do some things. So next semester, if grubs ever hold study sessions, go to them. Hint, hint, wink, wink. He will literally put questions on the test in that study session, which I didn't know about when I was a commuter student, which I thought was unfair because I didn't have a car at the time, so I could never make it. So because it was the day before the test, you had a study session, so you would at least get 3 or 4 questions right. So yeah.
Do you think you'll still hold study sessions again?
Next semester we are assuming where everything's going back to normal right now. We are assuming, but contracts have not been given out because we don't know. So it's weird. Okay, what's Catalyst do?
Lowers the activation.
D.
Looks
Good.
healthy. Fine.
Yeah. We asked about Catalyst a lot because this also prepares us for biochemistry. Which, hey, you guys love chemistry, right? From 181, remember like the citric acid cycle? Now you add Gibbs free energy to that, and you guys can figure out why it goes in that one direction and why it doesn't go reverse. They take analytical chemistry. Analytical chemistry is where you're using these big machines to do chemistry things. I took the class because I was a forensic science major, pre-med major, so they forced me to test the class, and I did analytical chemistry. So we had to, like, TLC plates? That's like baby analytical chemistry. I had to use like gigantic GCMS things where I took gas molecules, I shot them with a laser, and then shot them like the speed of light at a plate to hit it to see what was inside the compound. It sounds like fun. It is. It just depends on who teaches the class. Because if you don't, no, I don't have experience with it. Like they won't hire me for that class because you actually need like lab experience for that class.
So it's analytical
PChem, which is physical chemistry, and inorganic chemistry, which is this right here, is technically inorganic chemistry, but it's an introduction to graduate in electrochemistry. So it's like it goes even more in depth than all this stuff. So chem majors are different. They're weird people. If you like chemistry, do it. But like, I don't like chemistry that much. I like anatomy way more. Okay. Oh God, this is the first one, which I forgot how to do. At 400 K, the rate constant of the reaction is this. The activation energy is this with the rate constant. So what's going on here is I have 2 temperatures and 2 rate constants, right? Which means I need to do the equation that has both of those guys in it. The only equation that has that is this guy.
This won't be on the exam. Yeah, I think so.
Good, because I don't know how to solve it. Because even when I plug these numbers in, I don't get one of these answers. Even after like, is that the right way of doing it? Oh, it's K2 over K1. My bad. I always confuse those up. We are doing 35. Sorry, it's K2 over K1.
So is that 2 numbers?
Nope, still doesn't work.
Okay. So then
We can plug it in. So we are solving for K2, right? Because we are changing the temperature, which means we're changing the K value. So first off, you got to solve for one. You got to solve for the T's over here. So let's use, I don't know, purple. So this right here will be 1 over 400 minus 1 over 410.
how do you know which one's the first one? Whichever.
Because it has to increase in temperature. So 400 divided by 410. Also, it kind of has to be the bigger one first because you can't get a negative K value, right? So I got 6.1 times 10 to the negative fifth. Okay. EA is 41 kilojoules. I say no. You got to change that to joules. Why? Because you have to. And then that right there is going to deal with the weird one, which is the 0.00831 R value, not the 8.314. No, because we're going from kilojoules to joules. Yeah. Why'd you look at me? It gave you the R values, right? That is only in with Gibbs for energy. Because remember, it can equal 8.314 or it can equal 0.0821. Oh, 0.0821. Okay. Liters and ATM and stuff like that. You would use the, yep, you're correct. Use the other one, my bad.
So now
Maybe we'll find out. This is the time where everyone was jumping on to ask me questions. Also, we got tons of panic emails saying they missed the test. So, yeah, it's fun. $8.314. Got that. Times that number times my T value. Okay, let's do in black. The ln of K2, K1 is equal to 0.300. You guys get that or no? What? Sure, 301. Let me get a 1. Go ahead. There, okay. Going to replace K1 now with what's given to me, which was 3.2 times 10 to the negative second. So that's times 3.2 times 10 to the negative second. Nope, parentheses go down there. And then now I have the ln of K2 is equal to 0.009, right? The E value of that gives you what? 1.01. Well, that's what I've been getting the entire time. The answer now is C. I don't know what they did. Yeah, that's why I was confused with this one. I'll look into it, but there's not gonna be rate constants in you guys' tests, so we're just gonna move on. Because it's better to move on than sit here and do it all day. Okay. If the observed rate law of a reaction is this, what would have in the concentration of H be? So it's 1/2. What's 1/2? So just plug in 1/2 in for H. So 1/2 squared is what? Is it? 0.25. So did I double the, did I half the rate? Did I double the rate? I quartered the rates. So the rate was quartered. Yep, you just plug on, you plug on the inside, plug in and solve for it. Okay. Hey, 37. You guys know how to do these ones, right? Huh? These look familiar at all or no? Yeah. I'm going to quickly go over it because these should not be in your test. Because they're rate law, kinetics. Okay. So, no one's yelling at you. Let's solve for this guy first. I'm going to use the first two. So 0.2 divided by 0.1 is what? 2 is equal to 0.06 divided by 0.03 gives me 2. What will the rate be? X has to be 1, right? So it has to be the first power. Okay, that's what you do there. Next up, we're going to use, we're going to use top one and the bottom one. So we're going to do 0.05 divided by 0.1, which gives you what, Athena? 0.5, right? And then 0.015 divided by 0.030 gives you 0.5. So y equals 1. The answer is A. What? What did I do wrong? Huh? What? 0.5 bad? Yeah. But 0.5 equal 0.5. What do I do with what do I do with y to make 0.5 equal 0.5? I don't do anything. I just put 1 in. It's a 1-to-1 ratio. So it's first order. We actually might get done before midnight. That'd be nice.
Did you eat today?
Yeah, actually I had food today. That's why I'm like not dying and keeling over.
I feel that.
Okay. So what is the rate of consumption? What's that mean? How fast it eats it, right? How fast the reactants get used up? What's rate of production? How fast it makes it, right? So if I am making CO2, right? When compared to O2, what I can do is I go this over this times 0.60. The reason being is because what is the rate of consumption, right? For every 5 oxygens I'm consuming, I make 3 of these guys, right? That's why you do that ratio. Does that make sense?
I got 1.
Yeah, 1. Okay, that's what I got too.
That makes sense.
You put whatever you're solving for up top. It's kind of like ratios we do in 113. Okay. Hey, 39. What's the following picture shows this reaction?
I want to say A.
Want to see A?
Or like the first one. I want to say
So, do I have a 0 here? Do I have a 0 on B? Do you see a 0 anywhere around there? Then it can't be A because it's saying that K only equals A.
I meant like the first plot chart.
This plot chart right here, right? Yeah. It's kinda, you're correct as the first plot chart. The answer is D though.
What would the chart be then?
38 was B. The plot chart, it'd be all these plot charts. Welcome to Kinetics Lab, guys. That's why you guys are kind of confused in this one. I did that one for you. But you guys are Kinetics, there you go. Of course, what I'm here for. Okay, 40. Polonium 210 is the last nucleide produced in the decay of uranium, blah, 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 blah. Polonium basically decays into uranium and lead. The half-life of polonium is 138 days. How long will it take me to go from 100 grams to 20 grams? I can show you the mathematical formula for this, or I can show you guys how to think about it logically. What do you guys want? Which one do you guys want? Okay, the formula is stupid, so let's do it logically first. So, kinda, yes, but you have to do some, you have to manipulate it. Okay, so what does half-life mean? So, basically, in 138 days, half of what I have is gone. So what's half of 100? Okay, that took 138 days. So 138.4. Okay, am I anywhere close to 20 grams now? Okay, you know, so another 138 days pass. I get 25. Okay, do you see this? So automatically, I can eliminate A and C, right? Because I have to add these both up to get how many days it would take to get from 100 to 20 grams, right? Now, you can just you can logically think about this, right? So what's 138 plus 138? Is that Y bigger than B? The only leftover answer is D. That is one close to it. Because what you would do then is you would do 1/5 of a half of the days. Because 20 divided by 25 is 80%. So you would take the 80% times 138, and you would get kind of close to what you're doing. That's the logical way of doing it. I got 386, which is close to 231, 321. So it's, you would guesstimate between there. That's how you logically do it. And a lot of these half-lives, you can logically do it because they won't ask you to do the whole T1/2 because that's reaction order. That is part of kinetics. It won't be asked. So what does KSP equal? What is, yeah, you're correct. What does KSP equal? Solubility, right? So the higher my KSP value, what's that mean? Greater solubility or less solubility? More soluble. So I'm going to pick the one that has the highest KSP value, which is A. Please make sure you can understand scientific notation. The higher the KSP value, the more soluble it is in water. Are we in 42 now? Every substance will have its own KSP value. So for example, I'm trying to dissolve something like an ethanol, right? It has its own KSP value. Okay. I have a solution that contains some BA, I forget what BA stands for, and some calcium. I think it's beryllium, not beryllium, barium. There we go. There's so many B ones. You switch, you're a chem major? You switch majors? Oh, because Langley would love to talk to you. He's trying to get as many chem majors as possible.
Oh, he tried talking to me.
Yeah. If you do decent, he'll try talking you into doing chem majors.
One time I got one of the questions wrong in the quiz, and I told him like, no, I didn't. He's like, it's like, Google it right now. I dare you.
Yeah.
He Googled it, and it was right. And I yelled at him. And he's like, you should become a chem major. We really need like your stamina in chem. I was like, no.
Yeah, because all the people in there just are like the typical think of chem major. Think of Langley. Just think of small, young versions of Langley. And those are most of the chem majors.
Yeah.
And if you're a chem major, I hate to tell you that.
I don't think I've met a chem major.
They're very rare.
Yeah. In all of them.
Yeah.
I've never met a chem major.
Yeah.
I thought you were a chem major.
No.
I didn't know you were pre-med. I think you were
I'm pre-med. They didn't offer chem and also we don't take chem. We want to be a doctor, not a chemist. I can go into chemistry if I major. So there's no reason to do chem. That's why I like my major. I do a lot of stuff with it. Okay, so I'm adding beryllium with calcium, right? And they mix, and they kind of mix okay. What happens when is given and added to give? Okay, what happens when I add this guy right here? when I add CO3 and I add carbonate, it's going to react with one of these guys. Correct? Well, which one's it interact with? Well, I don't know. Right? We look at the solubility. The higher the solubility, the more likely it's going to stay in solution and not participate out. Make sense? So which one is higher, 8.7 or 1.6? 1.6 is higher? 8.7 times 10 to the negative. You're correct. I'm just showing people how to solve for it. If you're ever confused which one's bigger, subtract them from each other, right? 8.7 times 10 to the negative 9th minus 1.6 times 10 to the negative 9th. If you get a negative number, it means 1.6 is bigger. If you get a positive number, it means 8.7 is bigger. Huh? 8.7 times 10 to the negative 9th minus 1.6 times 10 to the negative 9th. And what number did you get? Big number or small number? Is it a negative number? Would it? Well, try it. Do it. One gives you a negative number, one gives you a positive number. One should be positive, one should be negative. That one's bigger. Try it. Trust my method. Why? Try it. Yeah. But they're both. The reason why it's not making sense in your brain, right, is because they're both the times 10 to the negative 9th power. They're the same one. Just so type in 8.7 times 10 to the negative 9th minus 1.6 times 10 to the negative 9th. You'll get 7.5 times 10 to the negative 9th. Which means that one's bigger by that much. It's barely anything. 8.7 is bigger, yes. Does that make sense or no? Type it into Google, see what Google says. I will type into Google.
No, I'm just curious. I really thought.
Which is bigger, 8.7 times 10 to the negative 9th, or 1.6 times 10 to the negative 9th. Oh. That's not going to tell me. Google, you lied to me. Just tell me which one's bigger. Use my method, it works. Okay.
That makes no sense.
Okay, then prove me wrong later on. For now, we're going to go with my method.
I'm not saying you're wrong. I'm
Okay.
just saying
Okay.
I'm wrong.
You're not going to say for the last 8 questions?
There's an emergency. I have to go.
Okay, I mean, if you need help with anything, please let me know.
Okay.
Hopefully everything is okay. Okay. So what this means is this right here, since is the bigger number, is going to stay in solution, which means this guy will participate out. So 42 is B. 42 is B because that one has a lower KSP value. It will participate out faster than the other ones. Yep. Okay, prove me wrong on some other time. Focus it later on. Okay. What is KSP? What? Solubility. What's a K stand for? Constant. What is the only way to change K? Change in heat. right? It's the only way to change K. Adding water will change the solubility, but it won't change the constant. Adding something will change the solubility, but not the constant. Removing something will change the solubility, but not the constant. Change in temperature will always change the constant. Doing A, B, or C will give you a Q value, not a K value. Does that make sense? Okay. Yeah, they are. Yeah, they are. Very few math ones. It should be most, yes. Oh, Athena, don't worry. I also put question marks in this one too because I was also confused. Because I do believe you that this one is, sorry, that this one is bigger. I don't know why it works. I put question marks everywhere. I do agree with you, yes. But I'm doing it just to get through the problems. Because I don't want to spend 30 minutes on one. Yeah. That's the answer. Yeah, I know. That's what Chegg says. Okay. So we have this weird graph, which is showing what's going on with A. It's decreasing. So is it be a product or reactant? It's a reactant. It's used up. B is increasing, right? So B is going to increase. Okay. So let's look at what's going on. Let's look at concentration. I start off with 5, and where do I end up? No, look at this axis. So I went from 5 to 1, right? So I lost about 4. I went from 0 to what? So I went from 0 to 4, which is a change of 4. So is it a 1-to-1 reaction? So I can eliminate A and B. Does that make sense? It's a 1-to-1 reaction. Okay. Then I need to do KC, which is products over reactants. So 4 over 1, hey, that's C. Because I have this left over, I have this left over, right? You told me B is products, right? So products over reactants. So 44 is C. 45. If HCl is added to solution of silver chloride, what will happen to the concentration of this? So let's kind of write this out, 45. Which is just this, write out the solubility equation. Because this will break up to this, correct? Silver chloride breaks up to silver chloride in water, correct? If I add hydrochloric acid, what's going to happen? What's going to happen to the concentration of chlorine?
Wait, it's going to be added to the complex.
What is hydrochloric acid? It's associated 100%, right? So I'm going to get tons and tons and tons and tons of chlorine ions. So my products increase. I have to shift towards the left, right? So what happens to the concentration of my silver? It's going to go down so I can make more silver chloride. Does that make sense? Okay. I lost you along the way. So do you agree that this guy has to go down to make these guys go up?
Yeah.
Okay. Then it's the inverse the other way around, right? If I draw double arrows here, right? These are now my reactants, it's now my product, right? So if I force it this direction, this arrow takes charge, and the purple arrow becomes what I look at. Does that make sense? Does it make sense?
Yes.
Oh God, that was all. Okay. Okay. Hey, entropy is what? That's one way of looking at entropy. It is randomness. So what has the most randomness? Gas. To have gases here. What's next? Do you have any liquids there? Is that an L? What's that? AQ is technically, it is a liquid, but it's less than so. But yes, it's technically a liquid. So that's gonna be the first one. It's a liquid with a solid dissolved into it. Okay. Uh-oh, I have two solids. Which one do you think can do more stuff? The one with more stuff in it or the one by itself? Think about you and your friends. You got you and your friends that cause more havoc if there's more of you than less of you, right? It's just you by yourself, how much damage can you cause? But if it's your friend, you can cause way more damage. So the answer is D. So, 48. Delta S. Delta means products minus reactants. Product is the concentration of NH3. Oh, I don't want to do 47, but fine. Okay. 47 is also one I don't like either. So which one does not have a delta G's value of 0? Exactly. There is a weird, obscure rule you do not need to know about. The answer is C. It's iodine. It's just a weird rule because of where it's located in the periodic table. It's located far enough down where it can start doing some weird things. You can break the octet rule and be annoying. Yeah. That's why it's iodine. That will not be in the test. Do not worry about that. That is like going to be graduate level chemistry things. I don't know why it's asked, but yeah, it's that one right there. Okay, products minus reactants. So we have a concentration of what? Yeah, you do biochem. And OChem. Yeah, the MCAT has OChem on it. You have to know. So 10% of what you all the OChem you need to know for the MCAT, you need to know for med school. Only 10%. Yeah. Yeah. And it's the easy 10%. It's like, oh, an acid, you add a proton. I'm to add a proton to this enzyme or this protein structure. Oh, it goes here. What's that do? Oh, it just changes the shape a little bit and opens up like an enzyme. It's enzymes open up and close with a lock key mechanism. Yeah, that's it. It's great, isn't it? Don't worry about drawing or adding or any reactions. Yeah. If you're a pharmacist, then it's different. Because you have to make the drugs. You have to figure out how the drugs act like, how does this drug act with this enzyme type of thing? So you do pro-drugs and stuff like that. If you go ask a doctor why like pomegranate juice interferes with antidepressant meds, they won't know why. Yeah. You can't eat pomegranates with any antidepressant medication. Yeah, you just can't. Because the body releases an enzyme to digest pomegranates that interferes with medication. It actually makes antidepressants stronger. Yeah, some of that, yeah. So you can't take melatonin pills while on birth control. Because estrogen and melatonin are similar to each other. More pathophysiology. Oh, good. I like talking about anatomy way more than chemistry. Okay, now minus reactants. Concentration of N2. So put that there, 193, and I multiply it by 2. I put in 192, and over here I have 115. Hey, just look at these problems. Can you do mental math? Is this guy going to be smaller or bigger than these guys? Just look at the hydrogen. 115 times 3 is way bigger than 293 times 2, right? So you can eliminate any of the positive answers. Good. Now you can plug it in and figure it out. You get B2. Okay, does that make sense? Okay. So, you're given delta G, you're given temperature, ask find K. You're going to use the delta G is equal to negative RT ln of K. Problem is, this has to be converted into joules. So 17.9 times 1,000, not 100,000. Oops. There you go, 1 less 0. Minus 8.314 times 298 ln of K. We'll keep this separate. I'm just going to show everyone that stayed. And then e to the negative 7.22 is going to be that. Okay, 50. This is where you're going to look at the chart I drew last time for the last one. We go like this, right? Guys, remember this chart I made or no? Very, very helpful to have that. We don't have to do any math. So we have, so it's going to be delta H is negative, delta H is positive, delta S is positive, delta S is negative. So a good way of memorizing this is that the first box will be what you want delta H and delta S to be. You always want delta H to be negative. You always want endothermic reactions because those are good reactions. You always want a positive delta S because you always want randomness, right? So if you get what you want, are you happy? Yes, delta G will be negative, always be negative. Well, at the very bottom corner over here, I got exactly the opposite of what I want. I'm not happy, right? Delta G will always be positive. Memorizing this. This will always happen at high temperatures, right? Why memorizing this is that 2 positives is a high number. This right here is 2 negatives, which is a low temp number. That makes sense? So I have a negative delta H and a positive delta S. What does that mean? I am in this box right here, which I'm always spontaneous with. And comprehensive. Yay. Isn't too bad, no. Well, the last one took forever because it was all math problems. This one was all conceptual.